we're recording again. Sorry, I'm having a little trouble with this today. All right. So next we look at the research method of surveys. Surveys usually involve the person completing a questionnaire or being interviewed with a set number of questions in which they report on their own attitudes, opinions, behaviors, and so forth. Now, surveys work in a specific fashion. Let's say we want to know what is kind of typical in a particular group, but it's too expensive and too time consuming to study each person in that group. Well, how do we get a good idea of what's typical in that group? This picture here gives us a clue. Let's say our population, the group that we're interested in, happens to be these marbles that are in this jar. And we wanted to know, well, what's the ratio of red to blue marbles? Is it 3 reds to 2 green, or is it 4 to 1, whatever. But we don't want to sit there and count every last marble in this jar. How can we get a good estimate? Well, the answer is that we can take a random sample from this jar, put it into that jar, count that one, and that's going to give us a good estimate. Now, there's a couple things, though, that has to be done here to make this effective. First of all, we have to have a really random sample. Okay, so every marble in this big jar needs to have equal chance of being included in our sample over here. So equal chance of each person in that population, if they're people, being given that survey. Secondly, we do have to have enough individuals in our sample to make it work. You know, if we just took out 2 marbles from the big jar for our sample, that wouldn't be enough to get a good estimate of that ratio, right? And so same thing with surveying people. We have to have enough people in our survey. We can actually do mathematical calculations to figure out, well, how many people do we have to randomly sample to get an effective sample group. Okay, now if we do not have a random sample of our population, then we say that survey sample is biased. The results are not valid. We can't count on those results giving us any useful information. It's probably better off if we didn't even do that survey then. So what does a random sample tell us? It tells us what's typical of individuals that are part of this population that we've studied. Will the results apply to every individual in that population? No. Some people are what? Atypical, they're not typical. But the results tell us in general when we encounter someone from that group what we should expect. Now, there are a couple other things we have to attend to when we're using surveys, and one is the effects of the wording. The wording can change the result of a survey. For example, if we ask in a survey, should cigarette ads and pornography be not allowed on television, we're going to get different results than if we ask, should cigarette ads and pornography be forbidden on television? Now, in reality, it means the same thing. Either way, you're not going to have those. But notice people are going to reply differently. To our first question, not allowed, there'd be a lot more people that say, yeah, I think maybe that should not be allowed. They're going to agree with that more readily than if the question includes the word forbidden. They're going to say, with the word forbidden in the question, a lot more people are going to say, oh no, we shouldn't forbid that. It's a free country and so on. And so that's going to change the results, even though it means basically the same thing. So whenever you're looking at the results of a survey, it's really worthwhile to find out just what exactly was the question or questions that the people were being asked. because often that makes a big difference. So particularly ask that if the results of the survey don't seem right to you, and have a look at what they actually ask these people. Okay, okay, now here's something that shows you a survey gone wrong. So here's a guy holding up a paper, says Dewey defeats Truman. There's a problem with that. If you know your American history and the presidents, you know that there never was a President Dewey, that President Truman actually was the one that won that election. This was printed up by the Chicago Tribune actually the day before the election, and they rushed to get that paper out there and be the first ones to get the results out. That headline was based on a survey that they took of potential voters. So what went wrong? Why did their survey give them false results? Well, they did interview people all around the country. They did have enough people, but note that this is in 1948, and they conducted the survey by phone. See a problem there? Did they get a random sample of American voters? No. Why not? Well, in 1948, mostly just the wealthy people had phones. So what they ended up actually doing was just surveying wealthy voters who might have voted for Dewey, but not the remainder of the population. So notice how not having random samples can really make you look kind of dumb. Okay, so samples, what's typical of population surveys. All right, now we also get to observational methods as well. And so naturalistic observation involves observing and making a record of specific behaviors that would be in that person or animal's usual habitat. Now, when researchers do this, they strive to be, quote, a fly on the wall. In other words, they want to be unnoticed so that animal or person does not know it's being observed. You say, why is that important? Well, if you haven't noticed, when behavior is observed, it tends to change. And if you don't believe that, think about how you drive when you look in the rearview mirror and you see a police car observing you from behind. Yeah, you might drive a little bit differently. So examples of this might be Jane Goodall's study of the apes in Africa, at least at first, when she did not allow them to see that she was observing them. Or how about with humans? Well, scientific naturalistic observation of humans might occur, for example, in a park where the researcher sits on a park bench and observes families as they pass by looking for certain behaviors. So what we can determine through naturalistic observation is usual behavior in usual habitat. That's pretty useful, but we should also recognize that the conditions under which we make observations can affect what we actually see. A good case of that might be, imagine observing the chimpanzees in the zoo in Brownsville on a rainy day as opposed to a sunny day. We're going to observe different behaviors because of different conditions. So if we want to know general behaviors, then we're going to want to observe that behavior over many different conditions. Now, I've also included laboratory observation. Doesn't mention it in the textbook, but this is where we make observations in a sort of an artificial situation. Okay, so maybe we want to make observations that require the use of sensitive equipment. Maybe we want to measure someone's brain waves, blood pressure, heartbeat, and so on while they're sleeping to try to understand the various phases of sleep. Now, we don't want to change their behavior. We want it to be their natural behavior. So we bring them into our sleep lab, we connect them up to equipment, and then we make it as much like home as possible. We might even have them sleep there for several nights before we actually begin recording our data with that sensitive equipment so they can kind of get used to it and they don't even know exactly when we're going to begin recording that information. So this enables us to look at things that are more difficult to observe with the naked eye. And in fact, I mentioned sleep research. That's exactly how a lot of sleep research has been done. Very useful. Notice here again, the researchers making every effort not to change the behavior, not to affect the behavior, but rather just observe what naturally occurs. So to sum these types of research, these are descriptive types of research. Case studies, surveys, and observation describe behaviors as they occur without any influence on the part of the researcher. We can then take information that we've obtained through descriptive research, and we can look for relationships between various factors using what's called correlation. Correlation is a statistical measure of the strength and type of relationship between factors. Okay, so it tells us, are these two factors associated mathematically in any way? And if so, in what way? How strong is that relationship? There is then a number that summarizes this relationship. It's called the correlation coefficient. This is usually denoted as small r equals and then a number. So what are these numbers in correlation? Well, let's see if I can bring up this paper here. There we go. I think you can see that. And so here's how the correlation coefficient works. The number can range from +1 to -1. Oh, what's in the middle of our number line? You guessed it, a 0. Okay, all right. So being able to range from these numbers, if we have two factors that we are comparing, and we end up with a correlation coefficient of +1, this is called a perfect positive correlation. Okay, what's that mean? Well, what this means is when one factor goes up, we find the other factor goes up as well. When one goes down, so does the other. Or when we find one, we always find the other present as well. When one of them is absent, the other is also always absent. So going together perfectly. Now, let me give you an example of that. Let's say we've got two students, okay? Let's say we've got Robert and Gloria, just to make up some names. And so we look at their attendance at class, and we find that every time Robert shows up, Gloria does. On the other hand, if one of them is absent, say Gloria is absent, well, Robert is always absent then too. Okay, that is a perfect positive correlation. Or let's say we're looking at their test scores instead, and we find that every time Robert goes up 10 points on his test, so has Gloria. If Robert is down 10 points, well, so is Gloria, and vice versa. Once again, this perfect positive correlation, these things are going up and down together in exactly the same increments. It might make you wonder, do they have the same transportation getting to class in terms of the attendance, or are they cheating on the test, or do they just study together? Anyways, okay, we'll get to that. Does that mean there is a cause behind that, or is that just some mathematical association? Okay, now let's go to the other side. If our number comes out as -1, then we can say this is a perfect, probably guessed it, negative correlation. Now, How does that come out with our example? In this case, what we would have is, when looking at test scores, every time Robert has gone up 10 points, Gloria has gone down 10. Or every time she goes up 10, Robert is down 10, vice versa. Or let's say we applied that to their attendance at class. Every time that Robert shows up, Gloria is absent. Every time that Gloria is at class, Robert is not there. Okay, that is a perfect negative correlation. Notice it's a very strong association, but it in fact is opposite. Okay, things are moving the opposite way. So what you should know about these correlation coefficients is the further you go from zero either direction, the stronger the relationship is either direction. So let's say we had a correlation coefficient of plus 0.45, let's say. And we had another minus 0.88. Okay, which of these two is actually a stronger association, a stronger relationship? Be careful. In fact, the negative 0.88 is a stronger correlation. It is a more consistent relationship. Now, that said, it is an opposite relationship, but yet is stronger than this one. Now, in psychology, when we get correlations of 0.2, 0.3, if we're lucky, we might even get one in the 0.4 range. We get up there, that's real significant. Rarely do we get anything way up here, and almost never perfect correlation. You say perfect correlation? Yeah. Imagine perfect relationship. Think about your last boyfriend or girlfriend. Was it perfect? No. Almost never in psychology one of these perfect relationships. But even these down in here suggest that something significant is going on in this association. Okay, now, when we look at these correlation coefficients, let's see, let's go back to our other screen again. Note that this also tells us how well does one factor predict the other, okay? If we have our correlation coefficient, then we can know to what extent can we predict one thing by knowing the other. Now, when it comes to these, let me get my pointer here. Let's just try some examples here, guessing the correlation coefficients. So would you guess positive correlation, negative correlation, or no correlation? How about height versus shoe size? Well, pretty close to a perfect positive correlation, at least very strong, okay? And in fact, that kind of makes sense. Yeah, the taller the person, generally the larger the shoe. It would be pretty weird if it was the opposite. Or how about this one? For an adult, numbers of years in school versus numbers of years in jail. Okay, well, textbook said close to a -1, close to a perfect negative correlation, or at least a strong negative correlation. Now, I'm going to question that. I haven't looked it up. I'm sure that it is a negative correlation, but I'm not so sure that it's that close to a perfect relationship. Nonetheless, yeah, it does seem that, yeah, the more education the person has, the less likely they are to be spending time in jail or prison. That's true, but nonetheless, you see the skepticism on my part there. Okay, well, how about height versus intelligence? Is there any relationship between the two? And in fact, studies indicated no, there doesn't seem to be any relationship, any correlation between those two things. You can't predict a person's intelligence by knowing their height at all. Okay, so now what we should also know, though, is that correlation does not necessarily mean causation. Okay, so going back to the example we had of self-esteem and depression, if we tested those two things and found that low self-esteem did go together with depression, that correlation might mean causation. In fact, low self-esteem might be causing depression, but you know what? It could be the other way around. It could be the fact that when people are depressed, their self-esteem lowers. We don't know from that correlational study whether one is causing the other or the other is causing that relationship, or for that matter, it could be a third factor that is producing that correlation, that statistical relationship. In fact, it might be that distressing events both lower self-esteem and lead to depression, or maybe a biological predisposition lowers self-esteem as well as making people more vulnerable to depression. We don't know from that correlational study. This is important to remember. Correlation does not necessarily mean causation, because often correlational studies are mistakenly reported as cause and effect in the media. They may look at a correlational study of, say, eating a particular type of food and cancer, correlational study, and say, this study showed that this means that we should maybe avoid that food and so on. But we don't know from a correlational study where there's the actual food, or there might be something about maybe the type of person that eats that kind of food, or the environment of the person that eats that kind of food. We don't know for sure. We'd have to do actually a different type of research to know if that association had to do with causation. Now, correlation also can be useful for prediction. And so a couple examples of that. They have found that there is a significant correlation between suicide attempts and substance abuse. So statistically, these tend to go together somewhat. Now it's moderate. It's not a perfect correlation by any means, but significant. So what's that mean? Well, suppose that you're a chemical dependency counselor and you're trying to help your clients get off drugs. Well, what's one of the things that you need to be sort of watching out for in your clients? In fact, you need to be a little bit aware of the potential of suicide attempts, because in fact, given that correlation, those are a little bit more common in people that have a substance abuse problem. Now, we can go the other way with this too. Let's suppose that you're a clinical psychologist and you're working with a patient who's been depressed and has attempted suicide. What's one of the questions you should probably ask them based on this correlation? One of the questions you should ask them is, have you had a substance abuse problem? Because again, we know that substance abuse problems are somewhat more common in people who have attempted suicide. So that's useful for prediction. Also, we can use this to predict risks of various psychological disorders like schizophrenia or depression. Again, in looking at, for example, families in which both parents have schizophrenia, there's a 50-50 chance that their children will have it as well. Or if you have a twin brother, identical twin that has it, again, you have a 50% chance of developing it, and so on. So this enables us to maybe take steps to be aware of signs of that developing, or maybe to avoid situations that might trigger the development of that disorder and so forth. Now, one of the things, kind of harking back to what we're looking at and seeing how people evaluate information and why we need science again, is illusory correlations have to do with that confirmation bias we talked about earlier. Now, there used to be this idea that couples who wanted to have a child but were unable to conceive would become more likely to have their own child if they adopted. Well, when they actually did the research on this, they found out that couples were no more likely to have their own child after adopting than couples who didn't. And so that turned out not to be correct. Nonetheless, the idea persisted, and it's still kind of around now. Why? Because people, once they've heard that idea, they tend to latch on to that confirming evidence where there is maybe a couple who didn't have a kid, and then they adopted, and then they had their own, and say, there it is, see? But yet not noticing the many couples where that occurred and they didn't have their own child. So sort of not noticing the disconfirming evidence. So this plays into that confirmation bias. Okay. Now, what if we want to know, does one factor affect a change in a second factor? Are two things related in a cause and effect relationship? In that case, what we need to do is conduct experimental research. This is the only way to know cause and effect for sure. So because of that, that's kind of become the backbone of psychological research. Experimentation is the primary means used. How do experiments then work? Well, we know many factors influence our behavior. So in an experiment, what we do is we manipulate one factor while holding all other factors constant, controlling all other factors, and then looking to see, does that manipulated factor, the one that we've been manipulating, have an effect on a second one? Effects generated by that manipulated factor then would indicate that there's a cause and effect relationship. So maybe we should look at this a little closer. In the experiment, there are two variables. The first is called the independent variable. This is the factor that is directly manipulated by the experimenter. This is the one that the experimenter applies to one group, not another, or that the experimenter applies and then afterwards looks to see if there's been a change in something. So the independent variable is the potentially causal factor. So the question then is, will this independent variable have an effect on a second factor? The second factor then is known as the dependent variable. This is the outcome or result that the experimenter measures when it's all said and done. So the independent variable is imposed. They observe, has there been now a change in this second variable, this dependent variable? Now in psychology, the dependent variable is usually going to be some behavior or mental process that the researcher is studying. Now, maybe at this point, it'd be, oh, I'll give you this, okay. In much research, then, this is done by dividing participants into two groups. The experimental group is exposed to the experimental condition, the independent variable. The control group is not exposed to that experimental condition. They do not have exposure to that independent variable, although everything else is equal in this control group. Okay, maybe here's where we need to go to a little bit of drawing here again. So let's see if I can get that back up on the screen. Okay, and go. All right. So first of all, let's just make up a theoretical experiment. In our experiment, we want to know, does a particular new therapy, does that have an effect on anxiety? You know, anxiety is what? Nervousness, fear, that sort of thing. Okay. So our independent variable, which we're going to write as IV, okay, for independent variable, would be new therapy. And our dependent variable, the thing we're going to measure, dependent variable, which we'll just put DV for a dependent variable, will be anxiety. Okay. Now, how are we going to measure anxiety? Let's say we're going to use the Beck anxiety inventory. Okay, which is, and the person responds to a number of statements rating it inventory. Yeah, I can't talk and write at the same time. Inventory. There we go. And we can actually abbreviate that BAI. Okay. Yeah, it has 21 items that people respond to from 0 to 3. So actually, the scores on the BAI can be anywhere from 0 to 63. Okay. So we're going to divide our participants into experimental group. And the experimental group is going to be exposed to the independent variable. They're going to get the new therapy. Whoops. Yeah, trying to make it look like therapy. Okay. Now, the control group, on the other hand, they are not going to receive the therapy. Okay. So we then give the therapy to the experimental group. Control group doesn't get it. And then we're going to measure anxiety using the BAI. Okay. Now, in theory then, we ought to be able to tell if these two groups are different in levels of anxiety after the experimental group has gotten the therapy, well then must mean that the therapy is effective. Or wait a minute, is there something else? Oh, wait a minute, we don't know that for sure yet. Why? Well, what if maybe the cause of differences in anxiety in the end here, oh, by the way, this is the dependent variable, right? Dependent variable anxiety. What if the differences in the dependent variable here are due to differences amongst people in these groups? Oh, well, we have to have two groups that are basically the same in every way. You said, how do you get two groups of people that are pretty much the same in every way? Well, people always in my classes, they always say, oh, well, maybe you have to like search people out and you have to like interview them about, you know, how many years of education and how much they weigh and what's their age. And then you have to kind of match them up in groups. And you know what, that's kind of a good idea, but there are thousands of variables and who knows which of those variables might influence this. So there's another easier and sort of magical solution, and that is what we call random assignment. Now, what we do is we take our whole bunch of participants and we assign them at random to experimental or control group. So if we have enough participants, that means that we're going to distribute any differences equally amongst these two groups. Chance will do this for us if we have enough people. in each group. So we will end up with a group of people in each group, the composition of the group being similar in every way. So in terms of makeup of men to women in each group, educational background, age, and so forth. Random assignment, we're going to end up with two groups. Anything that we look at is going to come out roughly the same in those groups. We've done this. Okay. Now, so good. We've taken care of, we got two groups that are the same. This group gets the therapy, that one doesn't. So results are obviously due to the therapy, right? Oh, wait a minute. There's something else. There's something else that might influence the result. Remember, everything has to be the same in both groups, except for one group gets the therapy and the other doesn't. You say, well, that looks pretty much the same. But guess what? The experimental group is getting something. The control group is getting nothing. Now, when somebody gives you something, what does that do? Raises expectations. You know, if you were participating in an experiment and they gave you a pill, that would raise some expectation that the pill just might do something. And in fact, it might, even if the pill didn't have any real power. So we have to what? Have similar expectations. Well, how do we do this? Okay, well, this group, rather than getting nothing, they receive what we call a placebo. Okay, placebo is something that appears to be similar to the independent variable, but in fact has no power to influence the outcome. So in this case, what we might do is we might use a therapy that failed to produce changes in anxiety previously. So we know it doesn't do anything to anxiety, okay? So these people now are getting something, so that means they have similar expectations. Okay, so now we know if there are differences in the outcome, it's not due to having different expectations in each group, right? Almost. There is another set of expectations we have to control for, okay? And that is the researcher's expectations. So what the researcher expects to have happen can influence the results. Now, very directly, if they're a crooked researcher, obviously they can do other things to make the treatment that they have more effective, obviously. But even unconsciously, the experimenter might treat people in the group that they want to see a change in differently, even unconsciously. So what do? We use the double-blind method if we can. Double-blind study. And what's that? Neither the participant nor the research assistant that is administering the treatment knows which is the real thing. So neither the participant nor the research assistant knows which pill is the real pill and which one is the placebo. Or neither the research assistant nor the participant knows which therapy is the actual therapy we're studying, so forth. So this prevents then the expectations of the researcher from coloring the results. So we get that all in play. Now, if we see differences in the levels of anxiety between these two groups at the end, then we can know it's due to that independent variable. Okay, now, when we say differences, what do we mean? You know, because sometimes differences can be just due to chance, right? Just, you know how things are. Some days you're a little bit better at something than others and so forth. Some people just chance variations. So here's what we do. We look at these two differences and we use tests of statistical significance to determine, are the differences that we see here large enough that they're not likely to be due to chance? Okay, so we can actually do mathematical procedures to find out. Now, how confident do we have to be that this is not just a chance difference? In psychology, 0.05 probability, 0.05 is minimum. In other words, you couldn't get that result but 5 times in 100. If you ran that study 100 times, you'd only come up with that much difference 5 times in 100 by chance. Now, if it's a little bit more of a controversial thing, then we might even set that probability at 0.01, where there's only, what, 1 in 100 chance that that was actually a chance result. So we're confident 99% that, hey, that actually is a real effect that our independent variable had. Okay. Now, there's one other thing that we're going to look at as well, or at least one major one. Okay, we're going to look at the size of the effect as well. Now, here's where these numbers come in. So we're going to look at, maybe we find that, yes, the difference between these two groups is statistically significant. And let's say that, you know, anxiety was lower in the experimental group, suggesting that indeed that therapy does reduce anxiety, but how much? And let's say we find that out of 63 possible points, the difference between the two groups was only maybe what? 1 point. Okay, so yes, it consistently works, lowering anxiety, but what? Only a tiny bit. In practical significance, let's say that's not very useful. All of that work just to be only tiny bit less anxious. We need a better therapy. Okay, so we're going to look for effects that are significant in the real world, enough to make it worth our while. Okay. So I think those are, you know, the major things here when it comes to experiments. Now let me see if I can go back to our other screen and let's just see if there's anything we missed in the outline here. Okay, we had those groups, we talked about that, talked about random assignment, distributing pre-existing differences between experimental and control groups, talked about the double-blind procedure, the placebo as well. Okay. So I think we have it. Maybe just one more thing to point out to you here. There are also experiments where the experimenter might test people before and after a treatment as well. So that's another way of doing this. I just wanted to point that out. We won't go into it in any detail, but do know that's also a way of conducting that. So let's then finish off with questions about psychological research and ethics. Okay. So first of all, do results of laboratory experiments really apply to everyday life? Now, you might look at that and say, well, you know, these experiments we're doing are really very artificial, because in real life you have what? Not just only one item that changes over time, that independent variable. You have all kinds of factors that are varying, and that's true. So what we have though is, if we determine that some variable has an effect in an experiment, we then look at it in real life and say, well, how significant is that in real life? And as we test more and more factors through experiments, we then can figure those in looking at how people behave in real life, if we know how more factors influence them. So as we learn more by testing more things, we get a better picture of how things work. Now, another question that comes up is, well, what about experiments on people? Do psychologists experiment on people? And the answer is yes. It's one of our primary interests, after all, is how people behave and so forth. Now, then people then sometimes have some fears about that and some concerns. So there are ethical guidelines then that limit what the psychologist can do. So let me get up again here. Go back to this. Okay. All right. So let's go here. First of all, research must be voluntary. Okay. So the researcher must give the person the option to participate in the research or to say no. And this is what we call informed consent. The person who potentially might participate is told roughly what they're going to experience in that experiment, and then they can choose to participate or not. And they also have to be informed that they can drop out, quit the research at any point they want with no penalty, no questions asked. So this prevents researchers from coercing, forcing people to be part of that research. Research also has to be, we use the term harmless. Okay, now, what is actually meant by that? Ethical guidelines indicate that in the course of that experiment, the person will not suffer anything that is more distressing than they might occur in a typical day. So can the researcher bring those people in the lab and then inform them that a train just ran over their mother? No, that could traumatize people, quite obviously. It has to be within the realms of what would be a typical experience in a day. Okay, so they have to do that. By the way, research also then has to be reviewed by an institutional review board. I'll just put IRB, Institutional Review Board. So the review board looks at research proposals, what the researcher would like to do, and they decide, hey, is this actually going to be harmless? Have they taken care of informed consent? Some of the other ethical concerns. If there are some concerns that it might produce harm, the researcher is told, you can't do that. Go back, modify the plan until it has satisfied the ethical requirements. Okay, so this is again something that is in place to prevent researchers from just going off on their own and doing things that might be harmful. What else? Also, confidentiality is required. So any personal information that is collected, let's just redo that. Confidentiality. There we go. So any information that is collected about the person must be safeguarded so that it cannot be connected with the person it belongs to. Okay. What else? Oh, deception. Can deception be used in experiments with human subjects? Yes. However, the deception must be mild such that it's not harmful to people. And then the participant must be debriefed when the experiment is fully over and told about what deception was part of the experiment. Okay, so those are some of the most basic ethical concerns in psychological research. Now, another question people have is, well, why do psychologists sometimes study animals? And what about the ethical concerns about animal experiments. So let's talk about, well, why do they use animals in experiments? A couple reasons. One is animals, particularly more advanced creatures, are similar to humans physiologically, physically, and behaviorally in some cases. More similar to us, obviously, the more similarity in their behaviors and so forth. So we can learn a lot that potentially applies to humans through the study of animals, no doubt about that. Another reason that we might study animals is simply because, well, it's useful. If we understand how animals behave, that might help us in our efforts for conservation and taking care of animals appropriately. So there's another reason, just because, and then maybe just because it's interesting to know about their behaviors. Now, what about ethics in experiments with animals? Okay, so a number of guidelines are in place to protect animals. So what about harm to the animal? In psychological experiments with animals, the researcher, if there's any physical harm to the animal that would occur, has to justify that it's likely that that research is going to produce significant human benefit. And so they're not going to be allowed to do that if it's just for the hell of it, so to speak. They're going to have to show that we're likely to benefit as humans very significantly. So that rules out a whole lot of ideas people might have. Secondly, if there is any discomfort on the part of the animal, it must be relieved as much as possible. So just like you give a human a painkiller after a surgery, if there is pain involved, that is relieved just as you would with a human. Also, researchers are required to take proper care of the animals that are under their care as well, again, to avoid abuses and so on. So those are some of the guidelines in place there. Sometimes people wonder, well, isn't behavior just primarily a matter of one's culture and gender? And in fact, culture and gender are very significant influences on behavior. However, there are many other influences as well, genetic influences, physical influences, and so on. So you might say, particularly with biological differences, they might set sort of the background, and then culture and gender works on that. So we have to study all of those things together rather than just one or just the other. Now, here's a question for you. Is psychology free of value judgments? Is it completely objective? Well, nothing really is, okay? Even harder sciences, so to speak, there can be value judgments that influence how people interpret things. Case in point, here's a picture. What's in the picture? When I do this in class, we always have a big argument because some people say it's a duck, and then others say, no, no, it's a bunny, and we get in a big argument. Now, notice we're looking at the very same data, but we're drawing different conclusions because we have different experiences. And you should be aware of this, that when looking at evidence collected by psychologists, one psychologist might conclude this means A. Another psychologist looks at the same evidence and says, no, I think that means B, okay? So we have to weigh that then against our own ways of looking at things. So once again, we need to go back to the evidence and evaluate it for ourselves wherever possible. How about psychology potentially being dangerous? And some people, when they start to study psychology, they say, oh my gosh, this stuff could actually be harmful. And they get scared, so on. Well, here's the thing. Yeah, psychology, just like any powerful tool, can be used for good or can be used for harm. So your um, your responsibility is to sharpen your moral values so that as you learn about psychology, you do use it to benefit yourself, benefit others, and that you don't use it to harm other people or manipulate them in a negative sort of way. So make sure you're attending to your moral development as well as your intellectual development in the course. Okay, well, that was sure a lot for one session. So let's call that it and let's close this down. Hope you're having a great day and got some good notes out of that. And